Good morning friends, welcome back to Panika Tutorials. In this video, I want to discuss one of the GATE question which came in the year 2020 related to scheduling algorithms. These kind of questions will help the students to understand the concept in a better way. So I request everyone to watch the complete video for better understanding. First let me read out the question, then I will discuss the solution with you. Look at the question. Consider the following set of processes assumed to have arrived at 0 milliseconds. Consider the CPU scheduling algorithms, shortest job first and round robin. And they have given four processes such as P1, P2, P3, P4. They mentioned that all the processes has arrived at 0. So I have considered the arrival time as 0. However, they have given the burst time in milliseconds for each process. Processor P1 has a burst time as 8, processor P2 7, processor P3 2, processor P4 4. If the time quantum of round robin scheduling algorithm, for any scheduling algorithm, we will have two parameters. One is the criteria and another one is the mode. For a round robin scheduling algorithm, the criteria is time quantum and the mode is preemptive scheduling algorithm. So the time quantum they have mentioned as 4 milliseconds. Then what they're asking, the difference between the average turnaround time of shortest job first and round robin is what they are telling, and they are asking in the milliseconds. They have given four options, option A, B, C, D. We need to compute the average turnaround time of shortest job first and average turnaround time of round robin, and we need to find the difference. Okay, now coming to the shortest job first scheduling algorithm, the criteria is burst time and the mode is non-preemptive scheduling algorithm. So first let me compute the average turnaround time of shortest job first scheduling algorithm. To do that one, I need to draw the Gantt chart. Okay, so the Gantt chart always starts from 0 units of time. At 0 units of time, all the process P1, P2, P3, P4 have been arrived. So all the processes are in the ready queue P1, P2, P3, P4. However, the criteria for the shortest job for scheduling algorithm is what? Burst time. So we need to look at the each processor burst time, and the processor which is having the less burst time will be shifted to the running state or dispatched to the running state. So among them, processor P3 has the less burst time. So the processor P3 will be removed from the ready queue and will be kept in the running state. As it is a non-preemptive scheduling algorithm, how much time the burst time is required for the processor P3? 2 units of time. So it will be run for 2 units of time. Okay, and once it is done, it will go to the terminated states. Assume that all the processor does not require any IO operations. If any processor required IO operation from running state, it will go to the wait state. Now, once the P3 is completed, look at what are the processes which are there in the ready state, which is P1, P2, P4. Look at their burst time. P1 is 8, P2 is 7, P4 is 4. Which processor has the less burst time? Processor P4. So it will be dispatched to the running state and it will be run for 4 units of time. Okay, once it is done, it will go to the terminated state. Now look at what are the processes which are there in the ready state. P1 and P2 having the burst time as 8 and 7 milliseconds respectively. So P2 has less burst time, so it will be dispatched to the running state and it will be run for 7 units of time. Okay, so 6 plus 7 is 13 units of time. By the 13th unit of time, it will complete its task. Then P1 is there, it will be dispatched to the running state and it will run for 8 milliseconds of time or 8 units of time, and once it is done, it will go to the terminated state. So we got the completion time for each process from the Gantt chart. Okay, let me use that one completion time. Okay, completion time of processor P3 is 2, P4 is 6, P2 is 13, and P1 is 21. Once we got the completion time, we can easily compute the turnaround time. Turnaround time is completion time minus arrival time. So look at each processor completion time and arrival time. 21 minus 0 is 21, 31 minus 0 is 13, 2 minus 0 is 2, 6 minus 0 is 6. They asked you to compute the average turnaround time. How can you compute the average turnaround time? Average turnaround time is equal to sum of all the process turnaround time by number of process, which is 21 plus 13 plus 2 plus 6 by 4 is equal to 21 plus 13 is 34, 34 plus 2 is 36, 36 plus 6 is 42, 42 by 4 is nothing but 10.5. So average turnaround time for the SJF we got 10.5. You keep it aside. Okay. Now we will compute the average turnaround time of the round robin scheduling algorithm. Let me erase this one also. Okay. And even this Gantt chart. Now we need to draw another Gantt chart for the round robin scheduling algorithm. Okay. Let me use this much space to do it. Okay. Now look at the time quantum. They have given 4 milliseconds. So if any processor requires more than 4 units of time, it will be given only 4 units of time. Then it will be preempted and be shifted to the ready state. Is it clear? To solve the round robin scheduling algorithm, we will consider the ready queue and running queue. Meaning is that ready state and running state only. And we have the Gantt chart. It starts at 0 milliseconds. At 0 milliseconds, processor P1, processor P2, processor P3 and processor P4 all have been arrived. When all the processors has arrived at the same time, we will look at the IDs. Which one I need to give the high priority. See, when the arrival time is same, we will look at the processor ID, processor P1, processor P2, processor P3, processor P4, which is having the lowest ID, processor P1. So that will be executed first, then P2, then P3, then P4. Is it clear for you? Okay. So now processor P1 will be bringed into the running queue and it will require 8 units of time. Out of that 8 units, the time quantum is 4 units of time. So processor P1 will run for 4 milliseconds and it will be removed from the running queue. By the time any other processors came, all the processes came at once only. So this will be removed from the running queue, will be kept after processor P4 in the ready queue. It has completed once. So its remaining burst time is 4 units. Okay. Then processor P2 will be dispatched to the running queue. It needs totally 7 units of time. However, the time quantum is mentioned 4 units of time. Processor P2 will run for another 4 units of time. So its remaining time is 3 units and it will be completed because its time quantum is completed. Is it clear? And it will be scheduled in the ready queue. Now next is processor P3. So processor P3 will be dispatched to the running queue. It needs only 2 units of time. Even if the time quantum is 4 units of time, it will complete its task in 2 units of time and it will go to the terminated state. So we will run the processor P3 for 2 units of time only. Then it will be gone to the terminated state. We no need to keep it in the ready queue because it has completed entire task. Okay. Now processor P4, processor P3 is done. Now processor P4 is there in the ready queue. So we will dispatch it into the running queue. It needs total 4 units of time and even time quantum is also luckily 4 units. So it will complete at one go and it will go to the terminated state. Okay. Are you able to understand it or not? Processor P4 also done. Now processor P1 will be bringed into the running queue. It needs how much burst time? 4 units of time. So time quantum is also 4 units. So it will complete its task in this round and it will go to the terminated state. Next processor P2. It needs only 3 units of time. So we will run it for 3 units of time. By 21 milliseconds, processor P2 also completed and all the processes which are there in the ready queue has been completed. Is it clear? So with this Gantt chart, we can easily find the completion time of each process. Then we can easily compute the turnaround time and average turnaround time. Okay. Now look at the processor P1 when it has completed its task at 18 units of time. Processor P2 21 milliseconds. Processor P3 10 milliseconds. Processor P4 14. Okay. Then how can we compute the turnaround time? Turnaround time is completion time minus arrival time. 18 minus 0 is 18, 21 minus 0 is 21, 10 minus 0 is 10, 14 minus 0 is 14 only. Now what we need to do? We need to compute the average turnaround time. How can we compute the average turnaround time? We need to perform the sum of all the process turnaround time and we have to divide by the number of process. So which is 18 plus 21 plus 10 plus 14 by 4. Is it clear? I hope it is visible for you. Now 18 plus 21 is 39, 39 plus 10 is 49, 49 plus 14 is 53 and 10 is 63. Are you able to understand? See, I did not use any Kitt's law. 18 plus 21 is 39, 39 plus 10 is 49, 49 plus 14 is 63. 63 by 4, which is how much? 15 4s is 60 and you will have the remainder 3. So you will get 15.75. So average turnaround time of round robin is 15.75. Is it clear? What they have asked? Find the difference of shortest job first and round robin. Shortest job we got 10 and round robin we got 15.75. Is it clear? Now you find the difference between 10.5 minus 15.75. You will get the value as 5.25 minus, but they have asked us to do the absolute, but due to space constraint I have not written that statement, but they have asked us to find the absolute difference. Is it clear? You can write here absolute, but due to space issue I have not written, but it was very important because we got the difference as minus, so we have to compute the absolute value. What is meant by absolute value? If it is a negative, it will become a positive. So plus 5.25 is the right answer. So for this question, option A is the correct answer. I hope you have understood how I solved this question. If you still have any doubts related to this question or the concepts which I have discussed in this video, feel free to ask me in the comment section. I will try to clear your doubts as early as possible. Thank you for watching the complete video. Have a nice day.